Hello class and welcome to today's science lesson. So today in science we're starting our new unit, which is patterns in space. Patterns in space. And the first lesson is Earth's gravitational forces. That's today's lesson. Okay, so what happens when we drop a ball from a height? I've lost my ball somewhere. What happens when we drop a ball from a height? It falls down. No surprises there. We throw it sideways, goes across for a bit and falls down. We throw it upwards, goes up for a bit, then it falls down. Great. So the thing that's causing the ball to go down is a force called gravity. And it's pulling things downwards. But is it really pulling things downwards? So if I was standing in Australia and it's pulling things downwards, would I just fall off the earth? Of course we know. No, you wouldn't do that. You wouldn't fall off the earth if you're in Australia. Otherwise we wouldn't have Australians. That would be sad. Or kangaroos. We would have none of that. No, so objects are not falling downwards, but they're going down towards Earth. So being pulled towards Earth. So why is it we can feel the Earth's gravity pulling us towards it? Why do we feel that? Well, the reason we can feel it is the Earth is really big. It's got a really large mass. You remember the word mass? So mass is how much stuff something is made of. So my mass, I'm made of loads of stuff because I'm a bit fat. I'm made of loads of stuff, so I've got much greater mass than, say, this cup. It's a smaller mass than me. So the Earth has a really big mass, the amount of stuff it's made from. But actually, everything with mass exerts a gravitational force on other objects. So exerts just means it applies that gravitational force on other objects, pulls them in. So everything with a mass has a gravitational force on other objects. So for example, here we have this student here, rather large student, and he has a gravitational force. Yeah, even him. So, for example, his gravitational force is pulling that pencil towards him. And also that apple. So why isn't the pencil and the apple flying towards him? Why, when I walk into a room, do objects not fly onto me? Well, my gravitational force isn't strong enough to pull those objects towards me. And they've got the pull of the earth pulling them down. And just me, little old me, don't have enough gravitational force to pull them. So what about the pencil and the apple? So we said that everything with mass exerts a gravitational force. So does that mean that the apple is pulling the boy towards it, even though it's so much less mass? Actually, yes. So the apple is pulling the boy towards it. It does have this gravitational pull on the boy. It's just really, really tiny. You never notice it. And the same with the pencil. So what determines the strength of the force of gravity? How hard gravity is pulling on something? So the size, or really what I mean here is the mass of an object. So the Earth's got a really big mass, so a really, really large mass. It's made up of a lot of stuff. Okay, so that means its gravitational pull is really strong. But the moon has a smaller mass. It's made up of less stuff. There's a smaller mass, so its gravitational pull is much smaller. So when we're talking about mass, remember the difference between mass and weight. So mass, like we said, is the amount of stuff something's made of. So I'm made of more stuff than my mug. I have a greater mass than my mug. But weight is how strongly gravity is pulling something down. So they seem kind of like the same thing, but when we're talking about the difference between the Earth and the Moon, you can see the differences. So if I'm on the Earth or if I'm on the Moon, I have the same mass. I'm made of the same stuff, right? I don't change. I'm made of the same stuff. But if I'm on the Earth, I weigh more than I weigh on the Moon. That's because the Earth is pulling me down harder. It's got a stronger gravitational pull because the Earth is made of more stuff. It's got stronger gravitational pull, whereas the Moon has less of a gravitational pull because the Moon is made of less stuff. It has a smaller mass. All right, we're going to take a quick break here and watch some astronauts falling over. So on the Moon, the force of gravity is weaker. So it's not pulling the astronauts down to the ground like they used to. So it means they can jump and bounce around, but obviously fall over as well. So how strong the force of gravity is doesn't just depend on the mass of the objects, but also depends on the distance. So if objects are closer together, there's a stronger gravitational pull. Whereas if they're much further apart, there's not such a strong force. So you could think of it like if you were right near the surface of the sun, gravity would pull you right in there, right into the sun. Whereas if you were right outside the solar system, maybe the sun isn't pulling you in quite so hard. The force of gravity is much stronger when you're close together, much weaker when it's further apart. So one way of thinking about gravity is that objects with a really large mass, like the Earth or the Moon or the Sun, are actually bending space around them. So you see here in this picture, the Earth it's like a big heavy weight, and it's bending the whole of space around it. Imagine the Earth is like a bowling ball on a trampoline, and it's bending the trampoline down it. So when you think of the Moon going round the Earth, the Moon orbiting the Earth, you can see why the Moon might do that now, can't you? It's like the Moon going down the drain in your sink. It's like a cone, and the Moon is going round and round and round. And this obviously also applies to the Sun. The Sun has a much greater mass than the Earth, so it's causing this big bend in space. And you can see from this picture that the Earth is creating its own bend in space from its gravity. Okay, so here we have a video of this professor demonstrating the same thing. So the weight in the middle is the Sun, and the little marbles that you have are the planets. So you can imagine that the mass of the Sun is bending space, but it's causing this gravitational pull. Right. So let's watch this video.
The explanation for gravity is that matter bends space. And so you put mass in a place in space, it warps space-time, and objects are not feeling a force of gravity, they're just following the natural curvature. And so this is a sheet of Lycra. Where do you get this? This is my old bike shorts. No, there's literally a spandex.com. You can get a sheet like this if you buy the sale stuff, so you don't care what it looks like, right? For like $20, maybe less, depending on the sale. And so you put matter, and it warps space-time. And so if I have another object, it also warps space-time. They feel that, and they're attracted to each other. And so that's Einstein's picture of gravity. Objects warp space-time, feel that curvature, and move accordingly. And if you have more mass,
you're right there on that.
Oh. If you have more mass, it's going to bend space-time more. And so if you have objects here, they are going to respond to that, right? And so you put something there, now it's attracted. Now, in reality, that big mass would feel the warping of space-time by the marble too, right? It would move a little bit, but we usually ignore that. You know, the Earth makes the sun move a little bit, but it's so small you can ignore it. The moon makes the Earth kind of wobble around a point 3/4 of the way from the center of the Earth. We usually don't account for that when we're looking at satellite motion. Well, instead of just letting go of one, what if I give it a sideways push? Now it orbits. Now it's losing energy, which wouldn't happen in the solar system, right? Not noticeably. There's some perturbations from other planets and things, but this one does lose energy and spirals in. If I don't push it as hard, it will do an ellipse for a while anyway. And let's put some more here. So one of the things I thought I would do with this is when you study the solar system, all the planets are going around the sun the same way. Why is that? Did God decide that he only liked clockwise, or depends on whether he's above or below the solar system, right? Why is everything going in the same direction? Well, the answer is it wasn't. Different directions. But there was a preferred direction. The disk it formed from had a slight preference one way versus another, and things going the opposite way got eliminated, and when it's all said and done, everything's going the same way. That works 90% of the time.
Okay, so there's a few more things to think about though if you jump out of a plane and you're falling towards Earth. Hopefully this guy has a parachute on. So we've got gravity, it's pulling him down. It's pulling him down, so it's shooting towards Earth. But what's this force here pushing him back up? What's that called? You should shout out your answer. Yes, exactly. Very good. Air resistance. Air resistance. So on the Earth we have an atmosphere with lots of gases in our atmosphere. So when an object is falling, these gases are in the way. So you have to push them out the way. So they're pushing back. So if something's falling, air is pushing back and slowing you down. So that's why a parachute works. You open up the parachute and you're opening up this big surface area above something. There's much more area for the air to push against. More air can get under this parachute and push upwards. And the more it's pushing upwards, then the slower you're going to be falling down. Okay, so here we've got a bowling ball and a feather. So if I drop a bowling ball and a feather, what's going to happen? I think we can all guess that the bowling ball is going to fall very quickly and thud against the ground, and the feather's going to kind of fall so slowly drift to the ground. But why is that? Gravity is pulling on both of them. Well, this is the air resistance. So, because of the shape of the feather, the air resistance is pushing much more against it and stopping it from falling so quickly. As you can see here, when we have air, the objects will fall at different speeds. But if we have a vacuum means there's no air. So in space or on the moon, there's a bit of an atmosphere, but not very much. So when you have no atmosphere, no air resistance, then objects fall at exactly the same speed, even if they're different weights. Now this is because although the ball is much heavier, it's harder to pull, it's harder to move. The force of gravity works on the heavy objects much stronger. And because that equals out, they cancel each other out. So feathers and a brick will fall at exactly the same speed if there's no air resistance. And I've included lots of links and videos in the description. So remember to like and subscribe, and look at the links in my description. Okay, right, that's enough for today's lesson, I think. Okay, goodbye.